All right, let's talk about the semester project questions a little bit more. And I'll go through from a biomechanics perspective, why you might want to select one question or another, or give some sense of a direction, but realize you can go a lot of different directions with these questions. Realize also that I could go through these questions in physiology of endurance performance and have a different approach to answering the questions. So really, it's sort of a perspective as where you're going to start on the question, but I'll go through a little bit of show and tell and talk about why these questions may be important for a triathlete to want to know an answer to, or someone doing endurance events in general. All right, so let's see, probably I got to keep my screen open and I need to go through the questions. So if you would, maybe to go along with this presentation, you should have your document open with the questions, and I'll go through these. I'll talk about them, and I'll do a little bit of show and tell with some gear that I have here in my remote studio. Okay, so I won't keep this document active, otherwise you won't be able to see the video very well. So open that document up, and I'll come back to this view. And let's go through the questions. All right, so what stroke rate should I use for swimming? Well, this rate question exists in each sport. So what cadence should I use for cycling? What stride frequency should I use for running? And each of these questions is really interesting from a number of different perspectives. What's interesting is if I just tell someone to start swimming, they're going to naturally pick a stroke rate, or if they start biking, they're going to naturally pick a cadence, or if they're going to run, they're going to naturally pick a stride frequency. The question becomes, why do you pick that rate for any of these sports? And those rates are not going to be the same, by the way. So your stroke rate is not the same as your biking cadence or your running stride frequency. So why would you pick one of those rates? You don't have to pick that rate. I can swim with a faster stroke rate or a slower stroke rate. I could bike with a faster cadence or slower cadence from running. So this becomes really an interesting perspective, or an interesting questions to try to answer. Is there some motor control issues, some motor coordination issues? Is there physiological reasons why you might pick one rate over another, or cadence? Or is there some mechanics, some impact forces, or maybe power being generated? Really interesting questions, both from a theoretical perspective of why someone moves the way they want to move or naturally move, versus a contrived movement where, as a coach, you say use a faster stroke rate or a slower stroke rate, something like that. All right, now you can measure stroke rate using quite a few different tools right now. My Garmin watch will measure stroke rate, so I can analyze my stroke rate afterwards. I also am working with a company that's developing this. This is a new instrument that's coming out that you put on your hand. You can actually put it on your legs if you wanted, or your forearm, and this will measure cadence as well. I also have somewhere, maybe I didn't bring it up. Oh, no, I do have them. Goggles, swim goggles that have a GPS unit attached and some accelerometers in the goggles. And this actually has a heads-up display, so I can actually view in real time some stroke metrics like cadence or stroke length or swim velocity. So I can get immediate feedback while swimming. All right, so lots of different ways you can go with this, from tying in some other areas, physiology, motor, biomechanics is what we're going to focus on, but you can tie in some other areas. And there's no correct answer, by the way. So, all right, so what wetsuit should I buy? So wetsuits come in different styles, different models. This is a full sleeve, full body wetsuit. And this is one model. This is another model. They're different. And you have different manufacturers. This is Hoob, okay? And each manufacturer, there's Roca, Xterra, all different types of Aquaman, all different wetsuit manufacturers. They all differ a little bit in terms of their neck design, maybe their zipper design, or how some of their neoprene is laid out, or where they put the seams, or what type of neoprene they use in different parts of the wetsuit. These wetsuits will range anywhere from, you can spend $100 to $1,000 on wetsuits. There's also what we call Farmer John, or a sleeveless wetsuit, no sleeves. I bought this one back in the late 80s for like $90. And I still like using it. All right, so which wetsuit am I going to buy, or which wetsuit am I going to use? May be dependent on the type of race I'm going to do, whether I need more thermal regulation properties. So when I did Norseman, I actually used a thicker wetsuit, more of a thermal wetsuit. Or I might want to look at how well the water moves over the fabric, and you would be talking about drag force with swimming, drag resistance force. And you'd be looking at the parameter called CD, coefficient of drag. And I'd have to also think about buoyancy, how the buoyancy is going to influence swim style, and whether or not the wetsuit design may interfere with swim style based upon restrictions at the shoulder. We're actually doing some research on that. So lots of neat things you can do with the wetsuit, from fit to zipper style, and why someone might choose one wetsuit over another. How do I stay warm during open water swim? Obviously, that's directly related to the wetsuit as well. And there's different thicknesses of wetsuit, so you would be likely talking about that. Will a swim skin help in a non-wetsuit race? I should have brought my swim skin up, but I'm sure you've seen them in swim competitions like Olympics, where someone will wear a very tight-fitting swimsuit that may actually cover much of the trunk as well as the lower extremity. Triathletes will wear a swim skin when a wetsuit is not allowed, okay? And a swim skin will help with drag resistance force. There's different types of swim skins, and they're really tight, and you've got to try them on, and it's a little work to get them on. And you consider wearing a swim skin when you know you're going to change clothes from the swim to the bike. Now, you may actually wear your bike clothes or the rest of your tri kit under a swim skin, and then you just exit the swim and take the swim skin off. Or you may actually do a full change if you're looking at a longer race, like an iron distance race. If you're doing something really short, like a sprint or an Olympic race, you're likely wearing your tri kit under the swim skin and just taking that swim skin off. And then as you exit the water, and then you've got your gear on for the rest of the competition. But swim skins, do they help? You know, how would they help? So you'd be looking at drag force equation. Should I train with swim paddles? I don't have swim paddles up here, but you put them on your hand. It increases the surface area of your hand. So now you'd be looking at the drag force propulsion equation. And you got to balance using a device like that with possibly putting too much stress on muscles that allow for shoulder movements. How do I increase propulsion force? This could either be through gear, like swim paddles or fins, or you'll be talking about swim technique and how you're trying to increase the drag propulsion force equation, or components of that equation. And how do I decrease resistance forces? That again is your drag force resistance equation, actually you'll find that the drag force propulsion and drag force resistance equations are exactly the same, 1/2 CdAv squared. It's just one is going to slow you down, the other one's going to speed you up. And so you just look at that equation to start looking at how something will increase or decrease one of the components. So a wetsuit will, in essence, decrease the coefficient of drag, CD, component of that equation. All right, I'm biking. I talked about the cadence one a little bit. How high should my seat height be? This is always a factor that triathletes talk about. And so if you read the literature on bike seat height, you're going to be looking at how high the seat is relative to what's called the bottom bracket. I'll hold my bike up so you see that. So if you're reading the literature, the bottom bracket is this axis that the pedals spin around. And some papers will look at the distance from the center of the pedal, okay, the center of the pedal axis to the seat. Okay, so you got to be careful about when you're reading the literature on how you're actually documenting seat height or measuring seat height. And then you've got to figure out which seat height is the right seat height. And most common rule is most people will have their seat height too high. So there's probably some benefit in really being careful about seat height, what height you have the seat at. It's two things that it's going to influence is the amount of power you can generate as a cyclist, as well as how aerodynamic you can get on the bike. What type of power meter should I buy? Well, there's power meters for pedals, power meters in the crank, and power meters in the hub. All right, so again, I'll hold this up. I don't have the power meters in pedal. Okay, I do actually have a set, but I don't have one on this bike. This is the pedal, and you can put a power meter in this. This is the crank, and you can buy a power meter for the crank, and that's what this one is. Or you can put a power meter in the hub or the rear wheel. All right, there's advantages and disadvantages of each of those, and we actually have a video on that, so you can even take a look at that. Where am I? What crank arm length should I use? That's the length of this part of the drivetrain, okay? Bikes typically come with a crank length of 172.5 millimeters. People have been experimenting with both longer and shorter crank arms. So what you're looking at is that equation, T equals FD perpendicular, because I'm pushing on the pedal, and that is going to create a torque around the axis of the bottom bracket. All right? So now the biking technique, you're looking at either being able to generate a lot more torque, or by going to a shorter crank, maybe you're generating less torque, but you're actually trying to increase your cadence. So really interesting mechanical problem. And when we get to the biking section, I'll go through the gear issue and how to, then I'll try to explain how the gear systems work. How do I reduce drag force? Well, I'm going to know that equation, 1/2 rho CdA V squared. Know each of the components in that equation, and how do you reduce each of those components. The 24-hour record for cycling is typically done at, or can be done at sea level, and it can also be done at high elevations, and different reasons for doing each of those. But that may influence, one of those may influence the density of the fluid that the person's riding through. In this case, the fluid is air. Or you can set up to reduce CD, coefficient of drag. And that's partly why I have these, triathletes have these bars here, is that you can get lower and you can reduce your coefficient drag. You can also reduce your frontal area. And by reducing those, you're able to reduce drag force, drag resistance force. What's rolling resistance? All right, rolling resistance is something we've been working on, trying to get a better understanding on in our lab. but it's the amount of resistance that this tire and wheel will provide to a bike. So if I just took this bike, I just pushed it and let it go, which I won't do, and I let it go, it will start rolling and eventually it will stop. Well, eventually it would fall over. But if it was able to stay upright, eventually it would stop rolling. The force causing it to stop rolling is, in essence, rolling resistance. There's a little bit more involved with that because you have friction at the bearing level, but the concept is rolling resistance will work to stop the wheel from rolling. There's different things that influence rolling resistance. The way the tire is constructed, the tire pressure, the tire width, as well as the wheel width. The tire is the actual soft part of this wheel system. The wheel is the actual frame part or the rigid part of this system here. What strike frequency? I talked about that. What shoe should I run in? Let's put this back. Oh, I don't know. Why didn't I have Arrow helmet in, or do I have it down below? I do have it down below. Okay. All right, shoes. So got all different types of shoes, from training type shoes for a trainer. This would be a maximum cushioning type shoe. Maybe a racing flat, something smaller and lighter and less cushioning. Or I'm sure you've heard or read about the Nike Air 4%. This has carbon fiber insoles in it. Why would I choose one of these shoes over another? Either for racing or training, and doesn't matter. And there's all different types of shoes. You go into a shoe store, and sometimes it's a little overwhelming to look at the number of shoe options to select from. And you have different types of elements in the shoe that either augment or minimize different types of movements. How do I use running power? A wearable technology device for running. This is an emergent area for wearable tech. So as I'm running, I can pick up power. You should know what power is. For cycling, it's actually been pretty common now for about 5 to 8 years, maybe 10 years, for cyclists and triathletes to be using the power meter. And running, it's just the algorithms are getting sophisticated enough now that parameter actually ends up being helpful. Remember, power is how fast we're transforming chemical energy to mechanical energy. So if I can measure power during running and power during swimming, which we're getting close to that as well, we're really getting an estimate of transforming chemical energy to mechanical energy. So we're really almost measuring VO2 by thinking about power. Pacing strategy. This is really interesting, how to cover a distance as quickly as possible. Now, the elite athletes just go as fast as they can for as long as they can, right? But for the mere mortals, there's actually a lot of different options you can do. A common one is to use a run-walk strategy where you run for 4 minutes and walk for 1 minute. I know that sounds odd, but you can actually find that you can, many people can cover a set distance faster when they use that type of strategy, because they're not getting to that point of the race where they're really slowing down and having a high amount of fatigue. Ultra running, it is really important to pace out when an ultra run, maybe like a 72-hour run, maybe even a 6-day run. Those types of runs, probably good to incorporate a pacing strategy that starts out slow rather than fast. And so there's some neat work on trying to understand pacing strategies. How do I avoid running overuse injuries? Yeah, if I take a group of people, 100 people, to train for a marathon, probably at some point in that marathon, probably 75 of them will have some type of injury. And of those 75, probably 25 will need to stop running because of the injury. Lots of different hypotheses on what causes an overuse injury. everything from impact force to repetitive movements, repetitive incorrect movements. And this is partly where the shoe comes back into play. We partly try to wear a shoe to minimize the risk of injury, but there's actually a camp of people that says that the shoe actually contributes to injuries. What's the relationship between impact force and running velocity? This is more a mechanical question. So we measure impact forces in the lab, having people run over the force platform. And this seems rather straightforward, but it can be a little bit tricky because you've got to figure out what type of running style you're going to use to run at different velocities. What is the amount of energy required to run a marathon? So this is a nice one that crosses into nutrition, but you're trying to use your mechanics to calculate the amount of energy needed to cover a particular distance. For a marathon or for a bike ride, there's actually, and I'll show you later on in the semester, a really sophisticated web page that you can use for biking to estimate the energy cost. And it takes into account road conditions, it takes into account surface conditions, it takes into account elevation changes, and has a pretty sophisticated algorithm to come up with energy cost. If you use your Garmin devices or other devices like this, you probably have software that tells you how many calories you use to cover a particular distance. That starts to get you down an answer to this type of question as well. All right, why should I buy an aero helmet? All right, so aero helmet. Let's see. Something like this. Gives sort of a nice enclosed feel to the rider. Air flowing over nice and cleanly over this type of helmet. These helmets, the aero helmets in general, can run anywhere from 200 to 500 dollars. So should I buy that and use that, or should I use more of a standard helmet? It's going to have a little bit more drag force to it. So is there a time that I would use this or that helmet? It comes into play, thermal regulation issues come into play in terms of airflow going over the helmet, and how fast you're going to go. You know, if you're only going to be targeting a iron distance event, bike ride, in maybe 8 hours, well, maybe the aero helmet is not going to be as effective for that type of rider versus someone trying to get under 5 hours. Should I incorporate plyometrics training? This is a really neat question. And do I have strength on that? No. So strength training in general is discussed quite a bit about endurance athletes. Strength training is an entirely different energy system, but what we found is that there is some benefit to incorporating strength training and/or plyometric training specifically for endurance events. So why and how? Now, 20, 30 years ago, the advice was not to mix the two types of training. So what's changed, and why are the majority of athletes incorporating plyometrics and/or strength training? Should I buy a time trial bike or use a road bike for triathlon? I only brought up my time trial bike here. It's just another frame up there. It's the same frame, just the one part of it. There may be times to do a triathlon on a road bike frame, and cost could be an issue, or maybe a hilly course versus a flat course. My time trial bike is much heavier than my road bike, so we need to think about the type of frame for a particular type of course, or we need to think about cost as well. How do I best prepare for running after a bike segment? So this is specific to triathlon. So once I get off that bike, how do I successfully run? All right. And so there's some neat work out there on what cadence you should be switching to for biking. or whether or not that's even an issue, in order to get off the bike and have a successful run. How should I monitor training load? This gets a little bit more into software or maybe wearable tech devices. So there's a lot of different software. I'll go through some of them, and I'll show you some or have some podcasts for you to watch as well. It's pretty neat what electronic information athletes are monitoring and analyzing to try to improve their endurance performance. What are the main injury mechanisms for triathletes? That could be shoulder based on swimming, could be knee problems for cycling, and then running could be another area for injuries. Interestingly enough, triathletes are mostly susceptible to the same injury patterns as runners. So running is a tough sport on the body. What's the relationship between nutrition and power? So this is getting towards how much chemical energy we have, what type of chemical potential energy we have, and how we can train the body to use the different chemical energy to generate power. A nice balance between nutrition and biomechanics, or really exercise physiology, energy systems as well. What is the importance of recovery to triathlon performance? I thought about adding a sleep question in here. Sleep would be really interesting, but in general, how do you improve your performance by recovering, or how do you improve your performance by not training? All right, there are some advantages and some techniques out there to recover between training sessions so that your training is more effective, rather than continuing to break your body down and not have a training response. If you took my 457, 657, I talk about Hans Selye's stress adaptation model, and that's an important model to consider when you're looking at designing a training program. All right, overall, the body of questions, hopefully this is somewhat helpful for you to narrow down the question that you're interested in. All these questions are super interesting from a triathlete perspective, and does help us make decisions either in training or equipment wise, or how to recover from an injury, or how to prevent an injury, or even what to eat. Okay, I hope that helps. Thanks.